we're going to call this presentation "No More Chaos in the Streets." So basically, the project that we're working on here is to kind of modernize and remodel how we're actually maintaining a lot of our streets asset data. And in this particular example, we're focused on street signs, street lights, and traffic signals. So what we've got going on right now is a few different feature classes that kind of overlap in a lot of ways. So first one we'll talk about here is our sign inventory. So it's managed and edited by a signs technician, primarily in the office, but they do use some field maps as well. And the way it's structured is that we have a parent post layer. So that contains like the structure specific data. You can see that at the top of that arcade pop-up. And then the post layer is joined to a bunch of different tables that are related to that post that contain different street sign data. So we've got a table for what's representing the highest sign on the post, and then the next one vertically down the post, et cetera, et cetera. And then we symbolize those with sign symbols after those are joined. We also have our streetlight inventory, which is managed by an engineering admin assistant. So totally separate building. And while they communicate with the signs technician fairly often, it's not like they're sitting next to each other or in constant contact or anything like that. And this one just contains one layer that has all of the information needed to manage this program. So that's the post and the actual street light information. And then finally, we've got our traffic signals, which to my knowledge are not managed and edited by anyone, which is mostly fine because they don't change all that often. It's not super common to get a totally new set of traffic lights in a mostly developed city like the one we have. But we have a layer that contains 1 point for the entire intersection's worth of traffic signals. So you can probably already see some of the sort of inefficiencies that we're dealing with. So we're going to take one intersection as an example over the course of this presentation. So the signs in the street lights each encode data for posts. And that leads to an issue where we have potentially two different sets of data that are actually recording the same thing. And in the upper right-hand corner of that image, you can see how we have that yellow circle that's a street light, and then the sign sitting on top of a post. And those are not coincident points. That post actually exists in two different data sets. And on top of that, that signal point that we were talking about represents greater than 20 different features, at least. There's 20 actual light boxes at that intersection, 10 of the walking person hold up the hand to stop walking pedestrian crossing lights, and then I don't even know how many electrical boxes, conduits, anything else like that. So when it comes to actually managing this data in a way that represents more closely what the real world is actually like, we've got some problems here. And for the most part, this has been something that has worked for a long period of time, but we've got a lot of opportunity for improvement, and that's what we set about to do here. So where we're going is something that looks much more like what you would see in the real world, hopefully without kind of overkill on data management. So we're on 1 point per feature here, which is better practice for asset management, because if you are tracking work performed on a feature, you want to know which feature you're targeting. If you're going to manage, say, that post data in an asset management system, having two different layers that each have an identical post or the same real life post in them is kind of a non-starter. Same with our traffic signal data. If we got to track when we need to repair a traffic light, just having one point that represents the entire intersection really doesn't help us understand the history of the work that's performed on any one of those particular traffic lights. So what we've got in that first photo there is kind of a quick snapshot of what that intersection might look like. And then finally, the second picture is what our asset management system will kind of show to a user who is actually tracking that work in that software. And we'll do a live demo of that in a little bit here. So the data management is cool. I'm kind of excited about it, but really the attribute rules for quality assurance is really where I think this is kind of doing a lot of the heavy lifting. So all of these feature classes that we're creating are going to have some attribute rules on them to help maintain that data consistency. So all of them will have an ID calculation that all stems from that parent post layer, which is now one layer that is related to all of the other ones in that system. It's going to calculate an ID. It's going to calculate an address or a PID, nearest PID, if those are present in the particular data set. And then we also have an attribute rule that will move all of the related features if one of those features is moved. And that will help kind of prevent, one user from maybe moving something and then we get sort of a geometry mismatch in the future. The signs data, in addition to having all those things I just mentioned, will also push the count of the signs to the post. So that'll track how many signs are actually mounted on that post. So whenever you insert or delete a sign, that will happen. And then the next two, the streetlights and signals, will both push a yes or no value to the post layer that will determine if there is a streetlight present or if there is a traffic signal present. And then finally, the signals also has an attribute rule that determines where the signal is mounted, whether it's on the post or on an overhead mast arm. And then lastly, we've kind of kicked around the idea of electrical utility data. We don't really record that right now, and I think it's kind of a future consideration and something that we will sort of incorporate this into because a lot of that electrical utilities is in service of traffic signals and things like that. Okay, gonna get out of the PowerPoint here, and we'll go to the live demo portion. So, go away that one. All right, so here's our Datafy application. So this is the intersection we've been looking at here. The whole intersection as represented with the streetlights, traffic signals, and the main sign on any given post. In real life, of course, it's a bit more complicated. So if we're just looking at this one post that we're going to be there that I was using as an example, there's 3 traffic signals, a couple boxes, multiple signs, overhead signs, and a street light. It's not super well represented by these 2 features right here. So we're going to try to improve that a little bit. I'll make that one go away. Okay. So first of all, we'll go over to the web map. So I recreated this one in advance of this demo, and I'll show you how I did that in a moment here. So we've got our post. It's got a unique ID, and it's got a lot of the same information that some of our 2 previous post layers, the signposts and the sort of structural information of the streetlight inventory, was previously encoding. It has a streetlight, it has a traffic signal, it's got 4 signs on it, and all of that was added automatically by way of attribute rule, because once we have multiple layers kind of handling related information, if you can avoid having our users make multiple edits to different layers when they really only want to change one thing, that increases their efficiency and reduces error. So we've got our street light. It's got that unique identifier that carries some information from the parent post and then tacks on something specific to the light. So we're kind of building a familial relationship by including all of that in its unique identifier. Same goes for the traffic signals. So in this case, we know it's mounted on a mast arm, so that ID also persists in here. And I've kind of gone around a little bit on whether or not I think it's necessary to include all of those things when we already have the relationships classes, managing this data. But similar redundant coding has saved me a couple times in the past. So for the moment, we're kind of keeping that in there. And then it's also kind of a nice visual check for anyone who's dealing with this data to say like, oh yeah, that is in the right spot. I know exactly where it's supposed to be. So here we have a post, and we'll go ahead and start adding some data to it so I can show you how that all works. So first we'll grab this mast arm, and I believe I got to turn on snapping, right? There we go. All right, start again. So said turn on snapping. Okay, whatever. We'll give it a shot. All right. So first step, we create this overhead mast arm. That's part of the overall system here. And we can click on it, and it didn't get any data because I'm guessing my first point is not coincident. Why did my staffing not turn on? Of course, it wouldn't be a live demo, right? Okay, let's try this again. Go ahead and clear that one out. Well, yeah, that part was working yesterday. We can show it off in Pro. The editing practice is essentially the same. All right. Nice to have a backup. Okay, here we go. So we're gonna begin our editing. Make sure snapping to point is on. All right. By coinciding with that post, we get that post ID right there. And then we can go ahead and add a sign. So we'll just pick one. It's not necessarily correct in the real life, but call it a main sign. And all this other information is useful for our signs team, but for our demo, we don't really need it. So we'll add a sign here, and then we can see over in the attributes that post ID and sign ID has both populated. And if we go back to the actual post, our sign count has gone up by 1, and that's part of that attribute rule that pushes the count to the post. And we can kind of continue going down here. So we'll just say this is an Eden Prairie streetlight. Add some information here, and we'll go ahead and drop that on. So when we add this here, what did I call it? The has light field is going to switch from no to yes. The symbolization of the post is based on whether or not there's a street light, a traffic signal, or both. So once we add that, that's going to flip colors because that attribute edit has been made. And we can kind of do the same thing for the traffic signal. So we'll just go ahead and add one of those as well. So both of those have changed here. We can also go ahead and add another edge. Add another sign. This would maybe represent, a freeway on-ramp sign right there, or a street name sign. So we've got a sign ID, a post ID. It intersected the arm, so we get that arm's arm ID as well. And our sign count incremented there successfully. On the web, this is our, our new, refresh that, get grumpy with me. So this is our new version of this streetlight inventory application that engineering administrative assistant manages. So that data just got added there. It's a referenced feature layer, so it's going to pop up in real time. But the streetlight inventory, that worker doesn't really care necessarily about the sign inventory. So she doesn't need all of that extra data on here. She just wants to know where are the posts and where's the streetlight. And since we have that, native relationship that we built in the database, we can flip back and forth between these quite easily. And it's the same with our sign inventory, which I'll also refresh that one. So that stop sign was added. We've got that mast arm added here. You can see we have a main sign right there. Let's switch over to it. The second sign's not working, but that's why we test. Okay. Wow, that should be, oh, you know what? I know why. I did not assign it a position. So I'll make that edit as well. And there it is. Okay, great. I did something right. Okay, so that's kind of how these two users would sort of interact, and they can make edits here that are going to be reflected immediately in, the other person's application that, references the same data that they have to sort of share. So if we change the condition of this from good to poor and update that, we're going to see it over here in the streetlight inventory as well. So this allows for better sharing of data, better sharing of information without having to actually, make phone calls or send emails about, updating anything. And then probably coming up pretty close on time here if I still want to allow for some questions. So I'm going to pop over to our asset management just really quick and kind of show how that will look. So this is Elements. This is our asset management system. And we're using, of course, the same reference data. So here I have our post page. We've got all of that good information from the GIS layer. And since the asset management system honors these built-in relationship classes, we can actually see every other feature that is related to that post kind of right here in this pane. So if we need to switch over to a sign because we need to perform some work on that particular sign, we can do that, provided my token doesn't need to be refreshed. We'll try that again. Go. Now we have our sign selected. We can get back to the post just by clicking that button. But if we need to generate some work here, we can certainly do that. And now we have a nice icon that is showing an open street sign task for field workers to go ahead and take care of based on the information that was submitted by either a different field worker or someone in the office. And so this map here in our asset management system will be available to both the engineering team and the streets team. And that is, because oftentimes, engineering staff will receive calls from citizens and they need to sort of direct the work of a field staff so they can create those tasks and have everyone looking at the same map using the same data as up to date as possible. So this one will include not only one of those sort of primary sets of the data, but all of them together, so we can view this as a holistic system, kind of as I was showing in that web map over there.